So today we want to look at integrals. We did the derivative of the natural log yesterday, so today we're going to do the integrals, which should be pretty easy because we're just going backwards from what we did yesterday. So you should be able to use the log rule for integration to integrate a rational function. I know you can all read. We're going to do some trig functions. Yeah. Because the integrals we have of trig functions are very specific trig functions. Secant squared, that kind of stuff. This will be able to get all 6 of the basic trig functions and come up with their integrals. And then, of course, you should be able to balance a checkbook. But I don't even think anybody does that anymore. They just trust the camp. What's that place where you put your money? The bank. Thank you. Wow. The camp. Yeah. You know, I don't know where you keep your money, but I take mine out to the woods and trust it with a bunch of college counselors at the bank camp. Anyway, we did this yesterday. Take the derivative of the natural log of the absolute value of x with the natural log of x for our purposes, and we get 1 over x. This wasn't very exciting. We actually dealt with this more. Natural log of u, the derivative of the natural log of u is u prime over u, and hopefully after the assignments the last 2 days you have that burned into your melon now. Okay. Derivative of natural log of u, u prime over u, every time. Doesn't require a lot of thought, just u prime over u, and then you get into the nitty-gritty of finding the derivative. Okay? Okay. So we're just going to go backwards. If the derivative of the natural log is 1 over x, then the integral of 1 over x is the natural log of x, and we talked about this already. Notice it's an indefinite integral, so you got to stick a plus c on the end of that, but we prefer number 2 a little bit more, which is the integral of 1 over u du, and you get the natural log of the absolute value plus c. This is.
Why does it have the absolute value?
Excellent question. The other one had the absolute value, but when we took the derivative of it, it pretty much came out in the wash. If you'll excuse the expression. This, it becomes relevant. So that absolute value matters here. And then the rest of my slideshow, other than the trig, is just examples of showing you how this goes into how this works. And it works just like all the other integrals we just tested on. Find your u value, take the derivative, do a u substitution. You'll end up with something like 1 over u, take the derivative, and you're good to go.
Could you go back for like 3 seconds?
1, 2, 3.
All good.
Those are slow seconds.
They were.
Okay, we'll start with something really simple. What's the integral of 2 over x?
2 ln x. Natural log of x. Absolute value, natural log of x plus c.
That's the same thing as 2 times the integral of 1 over x. You probably don't need this step, but I threw it in there just because I was feeling saucy. And then you just get that. Okay, just apply the theorem. 2 times the natural log of the absolute value of x. Plus c since it's indefinite. Easy? It better be. Oh, and then I got a little crazy there. How'd that happen? Better yet, explain to me what happened between steps 2 and 3. Cricket.
You took the integral.
Nope. No, between steps 2 and 3.
Oh.
See, this is step 1. Step 2.
Okay.
Oh, you counted this as 1?
Kinda, yeah.
Oh, I'm sorry.
I thought 1, 2, 3. It's okay.
1, 2, 3.
No, just no.
1, 2, 3, 4.
Yeah.
Okay. Okay, just hold on 1 second, okay? If you're not Tyler, what happened between steps 2 and 3? Tyler, what happened between steps 3 and 4? Nothing? John?
The property where ln a to the nth power, n if n is in front of the natural log, that's the same thing.
Yep. I did the opposite of the property we've dealt with, and normally if you take the natural log of x squared, you can take the exponent and move it out in front. It was already out in front, I put it back. I can do that.
You can.
Where'd the absolute value go?
You don't need it.
Why?
It's squared.
which is what that says. Good job. Should just have you guys do these. Okay, let's ramp it up a little bit. What's u?
X to the fourth plus 3x.
You want to go with the denominator as u?
Yes.
Yes? Everybody agree? Yeah. That's pretty much, hopefully you learned when we were doing UDUs that you want to choose the higher power, because when you take the antiderivative, you're going to reduce it to that. I don't know if I solved that. No, I didn't. I'll back up. I skipped the step of solving for dx, but this would move to the bottom over here, which just conveniently enough cancels with the numerator and reduces into something nice and pretty like the integral of 1 over u du, which is the natural log of the absolute value of u plus c. Plus c.
Plus,
What did you actually just say?
I literally just said plus c.
The whole, okay.
You asking me what I said? Oh, I said the integral of 1 over u du is the natural log of the absolute value of u plus c.
Wait, why did the 4x cubed plus you like skip that step knowing that they just canceled out?
Yeah.
Okay.
Yeah.
So then what did you go, so that's just, okay, never mind, just keep going.
Emma?
So you did prime over u. Oh, sorry.
I'm sorry, what?
Okay, you did u prime over u to find.
No, no u prime over u. That's derivative. This is integral.
The absolute value of u or x.
Yeah. I just applied the theorems. The integral of 1 over u is the natural log of the absolute value.
Didn't apply it.
Never mind.
I did apply it just now.
How? Wait, I'm being serious, wait, did you actually do something more than put you? Okay, you could just keep going, but I didn't think you actually did it. Yeah,
That's like.
That's just the theorem.
but don't you have to put it in?
Oh yeah, I'm not done yet. I still got to do that.
Oh, okay.
Yeah, I wasn't done clicking.
That was
Is that where your confusion was?
Oh, yeah,
Where the confusion lies?
I guess.
Okay. Can I just get rid of the absolute value now?
No.
No, because I don't know if that's positive or negative, so it's got to stay there.
What do you mean? You don't know if what's on, like, the entire thing?
The stuff inside. It's not like the last one we could get rid of it because it's always going to be positive. But this isn't always going to be positive. I could put in some numbers there that would make it negative, and so the absolute value's got to be there. It's got to be
What if-
positive.
What if that was 3x squared? That
What
would-
if this was 3x squared?
No.
The stuff inside.
What if it was
What
x
if it
to
was
the
x to the fourth plus 3x squared, then could you? Because they're both,
Because that would always be positive, then you could drop the absolute value. If you can guarantee that the stuff inside is always going to be positive, then you're good to go. Okay, now we look at splitting the fractions. So if things get a little bit crazy, and in this case we're defining crazy as the degree of the numerator is greater than the degree of the denominator, then we can split it and apply the log rule, which is what we've been doing so far. And so I got something like this. And this is kind of one of these weird ones that not going to pop up that often, but there might be 1 or 2 on the homework, and I want you to be exposed to as much as possible, so I'm going to show you how to do this. Notice that the numerator does not factor, the denominator does not factor, and so I have to come up with something else. If I choose if I try to pick a u here, let's suppose I make the denominator equal to u, it's not going to work out because I get the derivative of x squared plus 1 is 2x. That's not going to cancel with anything on the top. So you try the top as your u value. Well, the derivative of this is 2x plus 1. Doesn't cancel with anything in the bottom. Okay, so we can try splitting the fraction. Now, how do you want to split the fraction here? There's a smart way and a not so smart way that would be more difficult.
it would be x squared plus x over x squared plus 1. And then 1 over x squared plus 1.
No. That won't
Okay.
work. Emma?
Can you do x squared plus 1 over x squared plus 1 over plus x over x squared plus 1?
Correct. 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 There we go. So if we group these two together, like she said, then it becomes x squared plus 1 over x squared plus 1 plus x over x squared plus 1. So you can group them in whatever form you want. This one works out well because x squared plus 1 over x squared plus 1 is just 1, which we can now take the derivative of. Sorry, we're doing integrals. Now take the integral of. Just for giggles, what's the integral of 1?
1x.
X, correct. And how would you do the integral of this bad boy?
Split it. Rule of thumb.
Can't split that.
U.
Oh, you.
Me?
Substitution.
You. What would be u?
The squared plus one.
X squared plus 1 is correct. So that's what it would break down to, and I don't know if I continued. Yeah, here we go. So it chose, this is just 1, 1 dx if you prefer. We talked about that already. And then like Jake said, you take u to be x squared plus 1. So therefore du is 2x, which reduces this to 1/2. Again, I'm leaving out that substitution step now. Hopefully you're following along with me on that. Is that okay? So I'm not technically solving for dx here, but I'm figuring you're all following me there by dividing by 2x is going to cancel the x's up on top there and moves a 1/2 out in front. And that becomes 1 over u. What's the integral of 1 over u?
X natural log of the absolute value
Good.
plus c.
Plus c. And what's the integral of dx?
No.
X
Oh, yeah.
plus c. But do we need 2 c's? No, you just need 1. So substituted it back in there. Notice I got rid of the absolute value bars. Why? How's that be?
It's always gonna be positive.
It's always going to be positive, correct. If the absolute value bars are on there, it's not the end of the world. Okay, so let me make sure I say this right. If the absolute value bars are there and you don't need them, that's not as big of a deal as if you need them and they're not there.
Would you take off points?
I think did I say that right?
Yeah.
Yeah. So if you're not sure, leave them on there.
Would you take off points on our quiz if we left them on there and they didn't need them?
No.
Okay.
But I would take points off on your quiz if you needed them and they weren't there, because that shows you don't understand the theorem. Or don't remember that there's got to be an absolute value bar. Okay. The other nice thing is you can always just take the derivative and see if you did it correctly, because derivatives and natural logs. What's that squiggly thing called? Integral. Derivatives and integrals undo each other. So if I take the derivative of that, I can check to make sure that I started with the right function. I should get back to where I started. We're not going to. You'll have to trust me on that one. Okay. So some differential equations. Remember what differential equations are? You take a general solution. So you get a family of solutions, and you plug in some starting information to get it down to a specific solution.
Why don't you solve for the natural log of x?
I'm sorry?
And the last problem,
Hold on, let me go back.
why don't you solve
For the O line part.
the natural log?
Because I don't have to. I already did this. This got me from here to here.
Okay.
Okay? That's my final answer. Because if you start doing like u prime over u, then you're taking derivatives again, and that's not good. Because we're doing integrals now, we're not doing derivatives.
So is there always going to be a natural log in the answer?
You know I never use it always.
Most of the time?
In this particular case, yeah, you'll probably get a natural log in your final answer because that's what we're testing. Or practicing, I should say. Yes, sir?
Could you drop the 1/2 and make that a square root as well?
Oh yeah, if you were feeling saucy, you could do x plus the natural log of the square root of x squared plus 1. Just because you can.
Yeah.
Want to show everybody how smart you are.
Yeah, just asking.
No, it's a good question. Yeah, you could totally do that. But what you can't do is then cancel with the x squared.
Right.
Because that, you know that was
Yeah.
square. Okay, good. Okay, don't write this down, just watch. I'm going to show you how this works, but then eventually we're going to get to a theorem, because this guy does pop up quite a bit, and it's easier to just remember the theorem than it is to remember the process of how to find this. Okay, so I've got a differential equation. I'm starting with a derivative, and I'd like to work backwards to find the function. So, of course, you have to take the integral of both sides, because taking the integral of a derivative on the left side is going to get me back to y. and then taking the derivative, or sorry, integral of that guy is just going to be the integral of 1 over x, natural log of x. So, the log rule. What are we going to do for u? Well, we can do x, we can do x natural log of x, and then what? And oh boy, this just gets ugly. Watch this. So we get this. If we choose the natural log of x as u, then we get the du equal to 1 over x dx, which means now that dx is equal to x du. So what happens when you sub in then? Is that a good answer or a bad answer?
Bad.
Will things cancel?
No.
No?
Yeah.
Yeah. Well, one of you is correct. Okay. And the answer is yeah, it does work out well. This x is on top. It's not a 1 over x. This x from the original problem. This x from the original problem is in the denominator. So when you solve for dx, dx is equal to x du. Put an x du in there. That x is going to cancel with that, and it reduces to that nice little 1 over u that we've come to know and love. Which gets us that double natural log thing. You've seen that, I think there was a problem on last night's homework or the night before, where you had to take the derivative of a double natural log. Here, when we take the integral now, we get back to that double natural log. And again, that pops up quite a bit, so it's easier in this case to just remember that theorem. That way you don't have to derive it every time. You don't have to remember what to choose for u. You don't have to try a couple different things. Okay, good. Need a second? Okay. All right, so now we do the integrals of the trig functions. Now we'll have an integral for all 6 of them: sine, cosine, tangent, secant, cosecant, cotangent. And we'll start by doing this bad boy. I think we've done this already, haven't we? Haven't we taken the integral of tangent?
I think so. Is it secant squared? No, it's derivative.
All right, well, before I started, how do you think you'd do this? If you don't know the theorem for tangent, how could you get the integral of the tangent? Sine over cosine. And if you did it as sine over cosine, what would you choose as u?
Cosine.
Cosine. Okay. Right, sine over cosine. Love it. Choose u to be the cosine, and we get negative sine of x, so we're going to have a minus sign in there, and then where are we at here? We get that reduced into 1 over u. So it's going to cancel. This is important. Get a minus sign out front because the derivative of cosine is negative sine. And so doing the substitution, everything cancels out. We're left with a nice little 1 over u. This is also why we haven't done the integral of tangent yet, is because we get something involving a natural log, which would be that. So the integral of tangent is the opposite of the natural log of cosine of x. I forgot the absolute value. The absolute value of the cosine of x plus c. So let's suppose we were doing a cotangent. How would you find the integral of cotangent? Cosine over sine. What would you choose for u? Sine or cosine? I would choose the sine, yeah, and you go through the same process and you would do that over again. Same thing is true with secant and cosecant and all those others, which leads us to these 6 theorems. These two, the top two you knew already. These are new because we just learned how to take the antiderivative of some 1 over stuff. I have no clever way to help you remember this. You could just understand the derivation process, but the problem is on a test or a quiz, you're not going to want to sit there and redo the antiderivative of the tangent by writing it as sine over cosine and picking a u and doing all that stuff. So as much as I'm not a huge fan of it, you probably just want to memorize these. Add them to your stack of flashcards. I mean, there's a couple subtle things that you can remember, like if the answer involves a cosine or a cosecant or a cotangent, you'll have a minus sign in front of it. So the C's have minus signs. I don't know if that helps at all. Okay, we good?
No.
Okay, that's fine. Yep.
One more second. But like 5 actually.
What are you writing, a novel?
A little bit.
When I was a little boy.
Tyler's head's in the way. Alright, we're good.
You ever seen this before? Before I start it? Okay. Well, take a look at the picture first.
Oh no.
What do you mean, oh no?
I think I remember this, but I might not.
Are you gonna pop something
If
scary?
oh no makes no sense, I probably don't remember it.
Of course, that's assuming I can get it to work.
Oh wait, I do remember this.
Looks like a it looks like just a picture.
Yeah, so it's supposed to be dry.
Why isn't it working?
Oh,
Let's go.